Hello and welcome back. In this video, we're going to go about looking at some approaches to debug small programs. So many of our students come and have problems on the course, they hit a bug, they hit a snag, and we want to help you out so that when you hit those things, you have some things to try out so that you don't get too stuck. So the first thing I want to go through is the compiler. The compiler is our friend is the compiler. So the compiler is there basically to turn your code into code that we can understand as humans, all the syntax we are going to be using in MonoDevelop, all the stuff we're going to be writing, all the code is basically human readable. It's a human version of what the computer actually needs. And the compiler basically translates from the human version, or human-friendly version, to a computer-friendly version. If you were to look at a file that's designed for the computer to read, you'd find out it's actually completely illegible to a human. The computer needs things in a particular format. It's very, very hard to see what it's doing from the eye. It's very hard to read. And in fact, for every line of our code in our language we use to talk to the computer, the coding language, in our case C#, we might generate thousands of computer instructions that the actual processor inside your computer is going to execute. So basically the compiler is the guy or the program that takes the human readable to computer readable source code. And basically you might not think that code is very human readable, and it isn't. It's not a great format for creating and putting together instructions, but it's currently the best we have. And if you had a look at the code that the computer executes, you'd find that it's a significant step up. So why is the compiler our friend? Well, because the compiler has to understand all the code that we write to be able to turn it into code the computer will understand. And it's a great way to find errors and warnings. So the first thing I would recommend is listen to the errors and the warning in the compiler. That's really useful and important. Make sure you have no errors and make sure you have no warnings when your game runs, and make sure that every warning is investigated and every error is investigated. So when you double click an error on the compiler line, or if you're in Unity and you look at the console, there's an error there, you can always double click it and jump. It'll take you straight to the line of code that caused the error. And that's really useful. And what you'll find is that the error is always above or on the line that's mentioned in the error. And what you'll tend to find is that the error, often if you have simple syntax error, it'll be on the line above. Let's say you've forgotten a semicolon or you've forgotten to close a curly braces, then it will tell you there's an error on that line, but what you really want to look at is, do I have a syntax error above on the line above? So that's the first thing. The second one is you can run a build in MonoDevelop before you test in Unity, and you can use the shortcut Command B on OS X or F8 on Windows to run a build. And what that will do is it will highlight the lines of code that have warnings or errors attached, even before you jump into Unity, so that you can make sure that your code can run correctly, or at least compile correctly, before you get to your game. Now, understanding all the errors, the error messages, can be quite intimidating, and it's normal to not quite understand what's going on when you begin to program, and this is something that will take time and practice to realize what an error means. So if you see an error, have a look, dig through the code, try the other steps we'll show you, and then eventually with time you'll be able to understand a lot of those compiler error messages and see exactly what's going on. And in fact, eventually it'll become a superpower. I've had situations where I've sat next to somebody and I've seen the compiler and say, hey, this is what's happening with your code, this is on the line above, this is what's going on. And the fact is the compiler gives you a lot of information, it just takes time and practice to be able to realize what it means. But don't worry too much, it's quite helpful eventually. The second one is the Rubber Duck Sensei. Now, it's called Rubber Duck Debugging, and you can see our lovely little yellow duck right here. And the Rubber Duck Sensei is basically, every time you have a problem with your code, every time you have an issue or a bug, the first thing you want to do is have a rubber duck next to you on the table. And what you do is you turn to the rubber duck and out loud, actually speaking, you tell the rubber duck what the problem is. Not only do you tell the rubber duck what the problem is, but you also explain what you think is going on with your code. So step the rubber duck through all the code line by line, explaining what's going on. And eventually you'll come to see that the rubber duck is the wisest friend you've ever had, because the rubber duck will tell you when you have a problem with your code. It won't speak because it's far too wise to be using such a simple method of communication as actually quacking. It'll actually simply look at you and make you realize what the error is. So I highly recommend that anytime you have an error, you step through the code line by line, speaking out loud, explaining to the rubber duck what you think is going on. It is invaluable, and you can look at more information about rubber duck debugging on that link right there. I'm not joking. Some programmers really do have rubber ducks next to their computer. I personally try and write an email to a friend. That's always very useful. It's like, this is what's going on with my program. It's got this bug. I don't really understand it. And the more I write, the more I find out the solution on my own. So this is rubber duck debugging. That's another technique for you to try out. Next is assumptions, right? When you're debugging a program, you should assume nothing. Most bugs in computer code are actually due to your incorrect assumption of the programmer. So the programmer is sitting in front of the computer and is assuming something that isn't so. Computers are really good at doing exactly what we tell them to. And in fact, they're too good at that, right? So if you tell them to do something not quite right, they will do it quite blindly. And that's the point. The point is, most of the time we make assumptions about the state of our program that cause problems in future as the program progresses. So the first thing you want to do is list all the assumption before and after a method is called, for example, or any section of code. So list all the assumption you're making. Firstly, you're assuming simple things, right? The machine is on. I guarantee you, I personally in my programming life have had problems where my assumption about the machine being turned on or off was incorrect, and I spent weeks debugging this problem simply because I did not make that assumption clear and didn't check my assumption. So prove your assumption using prints or debug log messages to make sure that the assumption you're making about the state of your programs are correct. If you can write the assumption down in the code as comments, that's useful, but better yet, you write them down in the code as tests or assertions. So you're making the assertions that this is the state of your program before and after a particular section of code. This is invaluable. Knowing what is an assumption and what isn't is really useful. And whenever you have an assumption, don't think, oh, it has got to be like that. No. Prove your assumptions. There is nothing, but it's only an assumption unless you've proven it. So until you can say this is so because I can prove it, and I can prove it by writing out the output on my console, you have proved nothing. You have just got an assumption. So turn assumptions into facts using proof via printing or testing. And remember, this is not just you that is going to make those methods. It is hard. Programming is hard. And in fact, the Mars Climate Orbiter was a very expensive space probe that crashed in the Martian atmosphere because somebody made an assumption about the units used in the code. So instead of using newtons per second, they were using pounds per second or something like that. And the difference between metric and imperial unit meant the probe crashed. So this is hard. Assumptions matter. And if you are not careful, they can lead to very, very expensive and embarrassing blunders. So what's next? The next one is the minimum viable test case. When you've got a bug and you've got a problem with your code, you want to be removing as much code as possible while still having that bug. So you still have a bug in your code, but you're removing every bit of code that isn't relevant to that bug. So step by step, remove a line of code or remove a section of code or remove a function until you've got only the code that causes the bug. At some point, you'll be removing a line of code that is where the bug is, and the bug will disappear. The behavior will stop. That's really useful because you'll know exactly where the bug is being created, where the bug is being caused. It's also much easier to reason about smaller code sizes, smaller code samples. And it's also, we'll jump a little bit ahead of ourselves here, but once you've got a minimum viable test case, it's much easier to share with other people. If you've got a 5,000 line program, or even just a 500 or 50 line program, and the error is actually just in 5 lines, it's much easier for somebody else to reason about those 5 lines than it is to reason about the 500 lines. So a minimum viable test case does not mean you're removing code that works. You're making the smallest thing that actually reproduces the bug, not a line more. But the point is, it's still a fully working piece of code. It still runs and executes. It's just that it exhibits the behavior and nothing else. So that's the minimum viable test case, and we'll meet it again when we do how to ask good questions. And finally, debugging is like science. Use the scientific method for debugging. So roughly speaking, the scientific method is you make a hypothesis and you develop a testable prediction. So something goes wrong with your program, you make a hypothesis about why that is, you develop a testable prediction of given your hypothesis, and then you test it. So let's say my hypothesis is the variable isn't changed in those 5 lines of code. Well, okay, let's make a test. Well, I can test by printing the variable out before the 5 lines of code, printing it out after the 5 lines of code, and making sure that the variable has the same value. And then I test the prediction by running this code in my system, and I repeat until my tests agree with my hypothesis. Or I repeat until I now have to make a new hypothesis about what the cause of my problem is. This is really the key of debugging. Scientific method is really what you're going to be using for debugging your program. So don't forget, this scientist is the guy who can debug your code. At least it'll be what you look like after a crazy bug, I'm sure. So that is how to debug small programs. There are some great resources as well on this page. You can see Eric Lippert, who's a programmer who's written this great blog post about how to debug small program, and John Regger, I apologize if I'm not saying his name correctly, he also wrote something about the scientific approach to debugging in that blog post, in another blog post as well. As you progress through the course, this will become more and more relevant and should be hopefully helpful to help you sort out your problems with your code. All right, I'll see you in another video. Bye for now.